Several methods for solving quadratic equations, and this is all what is this video about. So let's define what do we mean by a quadratic equation. Any equation in the form ax squared plus bx plus c equals 0, where a cannot equal 0, is a quadratic equation. Now we can solve a quadratic equation by factoring, and when we do that, we're going to use the zero product principle. And what does this principle say? If the product of a and b is 0, one of them has to be 0. So the product of a and b is 0, a could be 0, or b could be 0. Now we're going to factor the first equation, and the first equation got factored into x minus 5 times x plus 2, so x minus 5 could be 0, therefore x equal 5, or x plus 2 could be 0, therefore x equal negative 2. Therefore the solution is negative 2 or 5. Now the second equation can be factored into 3x times x plus 4, so 3x could be 0, so x is 0, or x plus 4 equals 0. Therefore the solution is 0, negative 4. The last example, now in this example we're going to write a quadratic equation in general form whose solution set is negative 3 and 5. Now if negative 3 is a solution to my equation, therefore x plus 3 is a factor of my equation. If 5 is a solution to my equation, therefore x minus 5 is a factor of my quadratic equation. So let's write down these factors, and definitely we're going to set them equal 0. Now we're going to use the following method, first outer inner last terms, to write the equation. Therefore x times x is x squared, x times 3 is 3x, negative 5 times x is negative 5x, and negative 5 times 3, that's negative 15, equals 0. Now we notice the two middle terms are like terms, so we can simplify them. So 3x minus 5x, that's negative 2x, and therefore that's the quadratic equation whose solution set is negative 3 or 5. Now the square root property, another technique to solve a quadratic equation, is the square root property. And what does it say? If u squared equal d, therefore u equal plus or minus square root of d. Now we're going to see examples concerning that. So we need to solve using the square root property. So first of all, we're going to keep the variable on one side and the constant on the other side. Now we're going to divide by 3. Now x equal plus or minus square root of 5. Similarly, the second example. So always keep the variable on one side and the constant on the other side. Now we have negative, be careful. So the solution is going to be a complex number or imaginary number. Finally, the last example. Now completing the square. Notice in completing the square, we always have a binomial. So he always gives me a binomial, and I have to add to it a term. So this one will change into perfect square trinomial, and this one here is the perfect square. So let's see an example. What term should be added to each binomial so that it becomes a perfect square trinomial? Write and factor the trinomial. So we look at A, always at B, and we're going to divide it by 2. Now let's simplify. Therefore, the term we wrote is 16, and x plus 4 squared, that's my perfect square. Another example, so where do we look? At b, that's negative 7, and we're going to divide it by 2. Now let's simplify it. So notice the term we wrote is 49 over 4, and x minus 7 over 2 squared, that's my perfect square. Now my b is 3 over 5. We're going to divide it by 2. So keep in mind we have fractions. Therefore the answer is 3 over 10. Now we need to solve by completing the square. So first we need to keep the variables on one side and the constant on the other side. Now we need to add the term. Simplify. Now this one is a perfect square trinomial that gives me x minus 3 squared. Now we're going to use the square root property. Therefore that's the answer. Another example, always keep the variables on one side and the number on the other side. Example, always the coefficient of x squared needs to be 1. So we divided every term by 4. So we divided every term by 4 because always the coefficient of x squared should be equal to 1. So in this example, first we did simplification. We divided every term by 1. Now we're using the method of completing the square. Now the last technique is the quadratic formula. So we're going to see the last technique is the quadratic formula. So first I have to pull my ABC. So A is 1, B is negative 7, and C is 12. Now we're going to plug them in the formulas and simplify. Now keep in mind this example also can be factored. So it can be solved by factoring. Another example, my A is 49, B is 0, and C is negative 4. We're going to substitute them in the formula and simplify. Or we can use the square root property. Another example, we're going to solve it using the quadratic. My a is 3, my b is -1, and my c is -4. So my a is 3, my b is -1, and my c is -4. We're going to substitute everything in the formula and simplify. And we got the following solutions. Another example. So my a is 3, my b is 1, and my c is 3. Substitute them in the formula and simplify. Now notice here we got negative inside the discriminant. So the answer is going to be two complex conjugate solutions. Now, the discriminant is b squared minus 4ac. If it's positive, we get two real solutions, two distinct real solutions. If it's equal to 0, we get one repeated solution. If it's negative, we don't get a solution. So we're going to see examples using the discriminant. So for this equation, let's see what type of solution do we have. So we're going to calculate the discriminant, and it's 0, it means we have one real solution, or this equation has one real solution. For this one, let's calculate the discriminant, and it was negative. It means this equation has two complex solutions. For this equation, we're going to calculate the discriminant, and it was positive. It means this equation has two real solutions. And keep in mind, the complex solutions are conjugates, and the two real solutions are different. So let's see the first problem. A rectangular parking lot has a length of 3 yards greater than the width. The area of the parking lot is 180 square yards. Find the length and the width. So since we don't know anything about the width, we're going to say let the width be x. Then the length is x plus 3 since it's greater by 3 yards. And we know the area of any rectangle is less than the width. We're going to substitute the L by x plus 3 and the width by x. Now we're going to distribute the x. We can factor this equation, and upon factoring and solving, we got x equal -15 and or x equal 12. Since we're talking about dimensions, we can accept the dimension as negative. Therefore, we're going to take 12 as the value of x. Therefore, the width is 12 and the length is 15. Another example, a wheelchair ramp with a length of 122 inches has a horizontal distance of 120 inches. What's the ramp vertical distance? So we need to find x. If I look at this problem, I can solve it using Pythagorean theorem. So where c squared equal a squared plus b squared, so this is Pythagorean theorem. So this problem, we're going to solve it using Pythagoras. Now, definitely, we're going to take x as positive 22, and that's the ramp's vertical distance. So x equal 22 inches.